Alright, so now we're going to start the last set of notes. This is a big section though, it's going to take me quite a few videos to get through it. It's called Permutations and Combinations. It's the last type of counting that we're going to talk about in Chapter 6. But again, we're going to build off of this for the next 2 chapters. This is a very important big chapter. Permutations and Combinations. Permutations and combinations are a very special type of counting techniques which we use. They're formulas, permutation formula and combination formulas, that are actually built into your graphing calculators. We've done actually permutations before. We haven't done combinations before. Permutations can be done without the formula or with the formula. Combinations, however, you have to use the formula. Right? You have to use the calculator to find combinations. Alright, so like I said, these are specific counting techniques to use, but you can only use them if repetition is not allowed. You cannot have repeats. The formulas for permutations and combinations are based on the fact that repetition for my people, my letters, and my items or my numbers is not allowed. I can't pick the same person twice. I can't pick the same letter twice. Alright, no repeats. Permutations is the case where we're looking at ordered lists. So if I'm listing something out, or I have a lineup, or there's order involved, it's a sequence, right? A sequence of letters or a sequence of numbers, right? Codes or passwords, those types of things. Order is important. Or order matters because we have a rank to my selections, right? I have a different monetary value, different money values, right? If I'm giving away money and I have $1,000 to somebody, $500 to somebody else, $20 to somebody else, well, it matters. The first guy gets more money. Or if there's a rank to it, right? If I'm picking different people for different parts in a play, right? There's a rank to it. It matters if you're the person picked first, second, or third. It makes a difference. There's a difference between the first selection and the second selection and the third selection. It matters. There's a rank or order of preference. So permutations. And like I said, we've actually done permutations before. If you go back and look at the sequence examples in 6.3, where order mattered, because it's a sequence, and we didn't allow repetition, those were permutation cases. So the computer problem, which the letters in the word computer, and some of the number problems when we didn't allow repeats. Alright, the rule, well, it's a formula. Permutations is a technique that we use, and it has a formula that's built into the calculator. So the formula comes with the function, capital P stands for permutation, of, and then there are 2 variables, N and R. So it's actually, we usually say permutation and choose R. N is however many items I'm selecting from. So if suppose I'm making a code that's a sequence, so order matters, and I'm not going to repeat my numbers. So there would be 10 choices, right? 10 numbers I can choose from, and suppose my code's 4-digit long. Right? So I'd have 10 choices, and I'm selecting 4 of those. So it's 10, choose 4 of them. I have out of 10, I'm choosing 4 in my permutation. The way the calculator does it is it does NPR like that, and those are subs, so it's sub N, sub R, but it means the same thing. And what it is it's a multiplication, right? I'm choosing R things, so there's R factors. So R things, factors means things multiplied out. And every time I do a multiplication, I subtract. So the first choice would have had the total, however many I had, so there have been 10 items to choose from. But then the second one, since I'm not allowed repeats, would be N minus 1. And then the third one would be N minus 2, and then so on, N minus 3, N minus 4, N minus 5, until I had all my choices selected, all our choices picked. Alright, so again, we've done these before. Whenever we had a minus 1 down our line of multiplication, it was a permutation example. Now we're just going to have a formula in our built into our calculator to do it. And I'm actually going to show you both ways. The way we used before in 6.3, and then show it on the calculator as well. Alright, so the first example is a very simple example. Suppose I have 3 people, Ann, Bob, and Carol. So I'm going to let capital A be Ann, capital B be Bob, capital C be Carol. So I have those 3 people, and I've got to fill with those 3 people the positions of president, secretary, and treasurer. So I'm going to let P be president, S be secretary, and T be treasurer. Alright, the counting procedure for the number of ways that I can do that. So how many ways can I pick one of my 3 people to fill in those 3 positions? Alright, so first of all, is it a permutation? Yes, it is. first of all, I can't have repeats. Right, I've got Anne, she can only fill in one position, right? I've got one person to fill in one position. Bob can only fill in one position, and Carol can only fill in one position, right? No repeats. I've got one person to fill in each spot. Repetition's not allowed. Secondly, order is important, because there's a rank to it. Suppose the first position I fill is president, the second position I fill is secretary, and the third position is treasurer. Well, it matters which position you're picked for, because you have a different rank and different responsibilities. So there's a difference between choice 1, 2, and 3. Choice 1 is president with all of their responsibilities. Choice 2 is secretary with all of their responsibilities. And choice 3 is treasurer with all of their responsibilities. So there's a difference in positions. So order of selection matters. If you're picked first, it's different than if you're picked third. Right? First person picked as president, third person picked as treasurer. Order is important because there's a rank. Right, so the notation, well, it's a permutation. I've got 3 people I'm selecting to fill 3 spots. So it's 3 choose 3. Right? I'm filling 3 people in 3 spots. And the calculator, this is how it's going to go in. It's going to be 3, my permutations formula 3. All right, and then I'm going to go onto the calculator in a little bit and show you using my calculator. You don't necessarily I'm going to show you on the calculator because we'll get to big examples where you're going to want to use the calculator. But for something like this, you wouldn't necessarily have to. Right? You could solve it like we did in 6.3. I've got the president position, right? President position and the secretary's position and the treasurer's position. Well, there would have been six. There would have been 3 people to pick for the president spot. Once I pick the president, though, I've selected somebody, and so there's only 2 people left to select for secretary. And once I've picked the secretary, by default, whoever's left over is the treasurer. And so it'd be 3 times 2 times 1, which would come out 6 different ways to put Anne, Bob, and Carol in the positions of president, secretary, and treasurer. Now I'm going to go to the I am actually going to go to the calculator and verify this. So I'm using a TI-84. If you have an 83, it works similar. If you've got a newer 84, actually yours is a little nicer than what I'm going to have to do. And I'm going to kind of talk you through it. So I'm going to show you here on my TI-84. Alright, so if you've got something other than an 84, 83, you'll have to figure out where your permutations combination key is and use them accordingly. Mine is an older model, the one I've got here on my computer, so I actually have to type in my N first. So remember, N was 3, so I've got to type 3 in. Then I have to go get my permutations formula. If you've got a newer 83, you don't have to do this. You can just go get your permutations formula and then you fill in your N and your R. I don't. I have an older version, so I have to put 3 first in my here. So see, I've got a 3 there, and then I go into math. All right, under math, and if you go over here to the PRB, those are my probability keys. So I gotta hit over, the over arrow here until I get to probability, and then you'll look. The second one down is NPR. That's my probability formula that the calculator will solve, and so I select that. Then I'm not done yet. On my calculator, I have to put in my R. My R was also 3, so there's my N, my formula, and my R. Now, if you've got a newer model, yours just shows up blank spot here, P, blank spot there, and you fill in 3 for the N and 3 for the R. So again, if you've got a newer model, you just go ahead and fill those in after you've picked the permutations formula. So it's in the same location, you just fill yours out a little differently. Alright, then I hit enter, and it should give me 6, and it does. So like I said, if you've got a newer calculator, your calculator will have these little boxes, alright? And you'll fill it in with your numbers. Right, now it should give you 6. So if you've got a newer calculator. If yours is older like mine, you have to do the 3 first, then the formula, then the 3. But both ways should give you 6 out. Alright, now I'm going to list them. So I know there should be 6 outcomes. I'm going to list them. So the first spot's going to represent president, the second spot's going to represent secretary, and the third spot's going to represent treasurer. And I'm going to list them using A for Ann, B for Bob, C for Carol. And so I could pick Ann, Bob, Carol in that order, which makes Ann president, Bob secretary, Carol treasurer. Or I could pick Ann, Carol, Bob, which changes secretary and treasurer. Alright, that's everywhere. Ann can be president, so if I make Bob president, Bob, Ann, Carol. Or I could do Bob, Carol, Ann. That's the only ways Bob can be president, and then Carol, president. Carol, Ann, Bob. Carol, Bob, Ann. And there are these 6 different outcomes. Actually, the commas are weird. I'm going to leave them off. There's the 6 different groups with Ann, Bob, and Carol in different orders, because the order stands for the first position stands for president, the second position stands for treasurer, and the third position stands for, second position stands for secretary, the third position stands for treasurer. Alright, let's do another one, but this time we're going to up it. Suppose 2 more people decide to throw their names into the hat, alright, for our position. So instead of just Ann, Bob, and Carol, Dave and Ed decide they want to throw their names in as well. Alright, so now I've got 5 people to fill those same 3 positions. So still permutation, because I'm still going to only have 1 president, 1 secretary, and 1 treasurer. So 1 person. Once Ann's, Carol, or Dave are presidents, alright, then they're it. They can't be all 3 at once. Now, the counting technique changes because now I've got 5 people to fill in 3 spots. So there's 2 more people to choose from. I'm still, though, only filling in 3 positions, so it's 5, choose 3. So I've got 5 options to fill in my 3 choices. So permutation, 5, choose 3, or 5. If I don't use the formula, I still have 3 spots. Right, the first position was president, well, there would have been 5 people for that. I could pick anybody. Then once I've picked president, there would have been 4 left for treasurer, and once I picked treasurer, there would have been 3 left. I keep wanting to say treasurer second. 4 for secretary, and then 3 left for treasurer. So it'd be 5 times 4 times 3, which would make it 60 different ways. Right, on the calculator, so again, you go to the same place. You go to your math, go to probability, select the second one, the NPR. Now, if your calculator is older like mine, you're going to have to type in 5 NPR3. If yours is a newer calculator, you've got little boxes to fill in. But it should give you 60 either way. Alright, so it should give you 60 either way you do it. So again, I'll leave that for you to try on your own, but you should be able to type that out in your calculator. Right, then I would never ask you to list all of these. I'm listing them to get us to the next part of the problem. Alright, so here are all 60 outcomes. So this is actually the first 6 that came from just Ann, Bob, and Carol, right? Those are the first 6. Then I threw in Dave and Ed, so there's Ann, Bob, Dave, and all the different ways they can be president, secretary, treasurer, Ann, Bob, Ed, and so on. And there's my 60 different groups of 3 people if I had 5 people to choose from. All right, you'll look, there's 60 different groups listed there. And what I'm going to do is I'm going to use this 60 for the next part of the problem. Alright, so among Ann, Bob, Carol, Dave, and Ed, how many ways can I select a committee of 3 people? So I still have 5 people. There are still 5 people. And I'm still going to pick 3. So there's still a total of 5, and I'm still going to select 3 of them. But this time I'm just selecting a committee. Alright, so the difference is when I have a committee, order is not important. Because if you're the first person selected or the third person, you're still on the committee. There's no rank. I didn't say that there was a rank involved at all. It just means you're on that committee. You're one of 3 people on the committee, whether you're picked first, second, or third. So there is no order. Order doesn't matter. All right? Order doesn't make a difference. We still have no repeats because I want to pick 3 people. If I picked Ann twice and then somebody else, I'd only have 2 people. All right, so no repeats because I have to fill out 3 people. I have to choose a group of 3. All right, so order is not important. There are no repeats. So it's not a permutation. Right? It's something else, which we'll get to in a second. It's the other thing we'll talk about, which is combinations. Alright, it's a combination type. So order is not important. It's a group of people, whether you picked first, second, third, it doesn't matter. Right? The group Ann, Bob, Carol is the same as the group Carol, Bob, and Ann. Right? Because they're all on the committee. Same 3 people on the committee, and order didn't matter because there's no rank to it. Alright? And that makes it a combination, not a permutation. So this is why I listed them in the last answer. So using my last answer, can I list all of the possible committees? How many different groups of 3 can I pick if I choose from 5 possible people? So I'm going to go back here. Order doesn't matter, so I just want the different groups of 3. Well, that's any one of these in... Basically, I don't want any of the where I've reordered it. So I wanted the group with ABC, and Bob and Carol. I don't care about the rest of them because that's just reordering ABC. ABD's a different group. Don't want any of those though because I don't want to reorder it. ABE, and so basically it's just the top of all of these. And I don't care about the reordering that I did underneath. Alright, so if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there are 10 ways to select 3 people to go to a committee if I have 5 to choose from. Alright, so there are 10 groups of 3. Alright, if I list them, there was Ann, Bob, Carol, Ann, Bob, Dave, Ann, Bob, Ed. Make sure I get them right. Ann, Carol, Dave, Ann, Carol, Ed, Ann, Dave, Ed, Bob, Carol, Dave. Alright, you might want to double check me and make sure I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I believe that's the 10 different groups of people that can be sent on the committee. So there's my 10 committees. Those are the 10 possible committees of 3 people if I had 5 people to choose from. Which, like I said, this is a combinations type. Alright, so now we're going to get to the combination. That example was a combinations, and you have to use the combinations formula on the calculator because you don't want to list them out and then throw the ones out that repeat like I did in the last example. You're going to want to use the calculator for this. So combinations, usually the calculator. Permutations, it's up to you. Sometimes the calculator is not as fast as doing it by hand, but it's up to you. You pick. What's important about combinations is unordered sets and still no repeats. It's an algorithm that involves no repetition still. And order doesn't matter. So either it's not important like our committee, so any committee where it's just a random group of people, order's not important. Right? Combinations. Or if order can't be determined. An example we're going to get to is picking a handful of marbles or a handful of candy. Well, I reach into a bag and grab out a handful, they're all selected at once. Right? There is no order to it. I didn't pull them out one at a time. I pulled them out all together. Right? So order cannot be determined. So if there's no rank, placement, or difference of importance, order doesn't matter and it's the combination type. Along with no repetition. Now I am going to give you the rule just so that you know where it comes from. So combinations rule is, well, it's capital C is the formula. Combination. N choose R. N and R are the same things we had before. N still represents the total number of items. R is still how many we're choosing, so it's N choose R. In the calculator, it's the NCR, located the same place that we had the permutations formula. And what this formula does, it actually does the permutation, and then divides out all of the reordering. And all of the reordering would be taking how many items I have to the factorial. Right, the factorial, remember, is that number times itself where I'm subtracting each time. Alright, and that's what I'm going to get rid of. So if it was 5, it would be 5 times 4 times 3 times 2 times 1. And that gets rid of the reordering. Now, again, you don't have to do this. We'll be using the calculator, and I encourage you to use the calculator. So N is your total number of items. R is how many that you're going to choose. So the number of items you select from the total. Alright, so from the example above, remember I had 5 people, Ann, Bob, Carol, Dave, and Ed, and I was going to choose 3 of them to go on a committee. Alright, which again, order didn't matter, therefore it was a combination. And so I listed them out, and we're going to double check that when I did get 10 using the formula. And so I'm going to put in combination, 5, choose 3. On the calculator it's 5, combination, choose 3, and it should come out 10. Now I'm going to go verify it on the calculator. So again, it depends on your calculator. If your calculator is like mine, you'll have to type it in like that. If you've got a newer calculator, you'll use the combinations, and there'll be little boxes, and you'll fill that in with 5 and 3, and it should come out still 10 as well. Alright, so go to the calculator just to show you where it's at. So I'm going to clear out everything I have here. Alright, for that one clear. So I'm just going to go ahead and go find it. So the first thing I have to do, though, is put my number n in. So I have to type 5 in first before I get started. Alright, so my calculator's old. Got an older model, that's what you have to do. If you got a newer model, you don't have to do that. So if you got an older model like mine, you type 5 in, and then you go into math, over to probability, and now it's the third one down, right? NCR, which is my combination. So I pick 3, and then I have to type in my 3 again, because I'm picking 3. 5, choose 3. Again, if yours is a newer model, you'll put 5 in, there'll be a little box for the N, you'll put 5 in there, there'll be a little box for the R, and you'll put 3 in there. Hit enter, and it should come out 10, and it does. Alright, and so there were 10 committees. Alright, so we're going to stop the set of notes there. Basically, in the finishing out this section is just going to be practicing combinations, permutations, and neither cases. So you can recognize the difference when it's a permutation, when it's a combination, and when it's a neither case. Permutations and combinations, the biggest thing is make sure that repeats are not allowed. You can only use them if repeats are not allowed. If you're allowed to repeat, you have to use the stuff we did in 6.3. You have to use your and or strictly by multiplying and adding accordingly. Just a quick note about combinations and permutations. You can use the multiplication and addition principle with your combination and permutation formula. So you could have combination plus another combination, or permutation times another permutation, or mixing those together. Alright, they can be mixed together, and we'll look at some examples where we'll do that. And that'll be the next few videos on the notes, and finishes up here in chapter 6. Alright, so we'll wrap that up there.